Hey there, this is Max, and we're talking about the exercise 1 solution for vulnerability classes. In particular, we're exploiting a use after free vulnerability. So we're going to show this in two ways. First, we're going to show this with a graphical form where we show you nice diagrams and get a more intuitive understanding of it. And then we're going to walk through what this looks like in GDB and how you can debug this. I'm going to turn off my camera because my video is in a bad spot. So first, we need to allocate a player. This creates a data structure of 16 bytes that's going to have the name and the score. After that, we need to free the player. When we free the player, it puts a chunk into the T-cache, but it keeps the reference to the player pointer that I showed you in the exercise guide to begin with. Then when we call play, it also allocates a size hex 20. In order to exploit use after free, for the most part, you need to reuse that same chunk, and a lot of times that's going to require the same allocation size. In this case, that's exactly what you need to do. Now, when we call play, what actually happens under the hood is it overlaps the player structure with p-array. And this overlapping effect is what I like to think about for use after free vulnerabilities. I think it's the cleanest way to think about it. Because, like we showed in a previous slide, all the way back here, we have two pointers that are pointing the same section in memory. And they both think that this memory is represented in entirely different ways. When this happens, when the p-array gets 100, 101, 102, 103 written to it, the 103 value overlaps with the score of 25. And because 103 is greater than 101, then we win. That's all we have to do to get the flag. So this is the use after free, and we're exploiting it by writing to a value and then reusing the original pointer in an unattended way. So I can turn my camera back on, and then we're going to turn on the terminal. Beforehand, I didn't show this, but I think it's helpful for understanding what's going on. If we go to the bottom and we look at the play option, you'll notice that it's allocating a chunk of size x10 here. And this is line 133. Cool. So we're going to call Python 3 start. I'm going to put a breakpoint at 133 just so we can really see this in action. So to play this, we're going to first start with a malloc and call it a Maxwell. And that initializes our score to 0. If we go back down and we look at the heap, we can see a single chunk with the D50 right here. And this 250 size chunk you're probably confused about. This is actually the T-cache itself. The thread-specific cache is the first thing that's going to be allocated whenever the heap is used in a new thread. Kind of weird, but that's how it works. So we can effectively ignore that, though. If we do print player, we can see that this does line up with this chunk that we're looking at right here. The reason for the 16-byte difference is because of the different internal representations of it. The pointer to the prev size versus the pointer to where FD is at is the difference there. I go up and now we call free. We go back down and now we look at the bins, particularly if we look at the tcache bin command, we can see that this is 260. And if we do print player, this is also 260. So now we have the player structure has a reference to this chunk even though it's already freed. That's where this use after free vulnerability comes into play. So we're going to do continue. We're going to go back up. And I'm going to call use. This triggers a breakpoint because I wanted to see what this was going to look like. So right now, we have the free chunk. We haven't done anything with it yet. If we look at the Tcache, it's still there. If I do next, this will go to the next line in the source code. So at this point, it's allocated it, but it hasn't called add score. So if we look at the bins, we'll notice that there's nothing in there. That's because we aren't using it. It's been allocated at this point. And if we look at the source code for add score, so if you do add score, and we're going to do list add score. This might be easier to see. We can actually see what's happening. It's going to take that pointer we just allocated for the P array. It's going to add I plus 100 to all 4 slots, and then get a random value and return that value, with the highest possible score being 100. So if we look at the player structure prior to this write happening, and we dereference it, we can see that the name is set to all zeros because of the null pointer at the end of the linked list, and the score is just 0. But if we do continue and let this go through the entire operation of playing, we'll now notice that this tried writing other values. In particular, the score is actually set to 103. This is because of that write that happened. So now if we go up above, we do 1, we get the flag because the score is set to 103. So this is a really simple to exploit use after free. Go back to the slides. Cool. To recap, we create a user, allocate the chunk. We delete the user to free it. We then call play to allocate over the top of it and set the value of 103 in the overlapping slot. And then we call win to find our score. Has actually been written. This is a pretty fun challenge, I think. I think there's not too much happening, and it's easy to see how this use after free bug can be exploited. So congrats on solving this. Good luck going through the rest of it.